Okay, next up, Rachel Mayo is going to present a comparison of nutrient fluxes during stormflow and baseflow conditions in the Wailuku River to Hawaiʻi listen.
Is anyone able to hear me? Is anyone able to hear me? Thank you for the introduction. As you are all aware, my name is Rachel Mayo. I am a senior undergrad student here, and I decided to focus on my my thesis project on looking at nutrient fluxes at Wailuku River. So what we know about like coastal ecosystems is they depend on nutrient fluxes for primary productivity. And pretty much what fluxes are is it's just like a certain amount of concentration of a certain nutrient over a period of discharge over time. And these fluxes, they rely on fluvial transport, which is pretty much river transport from rivers and stream tributaries going into big rivers such as Wailuku. And these transports, they rely heavily, or they are heavily influenced by river discharge. And one thing to note about about nutrients is like the rise of excess, like if we have too many nutrients, it can cause overgrowth in these estuarine ecosystems, which, as we all are aware of with algal blooms, it can be pretty bad. One of the big questions that we're looking at right now in regards to climate change is like how discharge could be impacted. What we know here in Hawaii is that there's an expected increase in variable rainfall patterns. So that means there's going to be some days where there's not as much rain. There's going to be some days where there's a lot of rain. And what we're also seeing is like when on the days that we have a lot of rain, there is going to be it's going to be more intense, which means there'll be more flooding. There will be more fluxes of these nutrients in estuaries as they get pushed out into the ocean. And why we think that discharge being impacted by climate change is really important, it's because if we have an increase in the freshwater discharge from rivers into oceans, it could affect the thermohaline circulation, which can be not really a So for this study that I was doing, I wanted to focus on 3 particular questions about like how does discharge affect the concentrations. And for this particular one, I had done both forms of nitrogen and phosphorus, but for today's talk, I am going to be focusing on nitrogen. So I was wanting to look at how discharge affects nitrogen species concentrations. I was also wanting to look at how discharge affects the composition of like the total nitrogen that's in the Wailuku River. And I was also wanting to see how discharge affected the export of the nitrogen. So as we, with the Wailuku River, it's like the Wailuku River watershed. It is the largest watershed in the state of Hawaii, with the area being 653.2 cubic kilometers. The major, as we can see on this graph here, or this picture, sorry, the majority of the land cover is evergreen forest areas, followed by bare land that usually it's like a very common area for like development and urbanization. And what's very unique about this particular watershed is it experiences high levels of precipitation, as much as like 9 centimeters a year. That's when I last looked at it. So of course, with the current storms that we've been having lately, that number could have changed, but we'll see. And then the headwaters of this particular watershed starts at 3,600 meters. So for looking at the particular species of nitrogen, I focused on nitrate and nitrite. I focused on ammonium and the total dissolved nitrogen, which is pretty much all of those combined. The only thing was I had to do several calculations for dissolved organic nitrogen, which is pretty much, as we all are aware, we just subtract all of the inorganic forms from the total dissolved, and that would be what we have. So from August 2021 to December 2022, we went out to the Wailuku River and we picked up samples of water and we filtered it through like filter paper and syringes. And we sent our data, or we sent all of our samples to the analytical lab to kind of calculate how much of the nutrients we have. To calculate the discharge, we use the meter at the Honua that is used by the USGS. And so far for my results, what we are seeing is that dissolved nitrogen, out of all the forms of the nitrogen, we were looking at how concentrations were affected by base and storm flow. We were able to see that only dissolved organic nitrogen was the most significant, with the p-value landing exactly at 0.05. But it's kind of like unique what you think of it. And as we are able to see with this graph, the greatest amount of the concentration is at the base flow versus storm flow. Yeah. Okay, there we go. And then as we were looking at the how the largest component of the total nitrogen in our in our rivers, as you can see here on this chart, during base flow conditions, DON is the most dominant form, followed by the particulate nitrogen, followed by nitrate and nitrite together. Oh wait, no, sorry, mixed up here. This is nitrate and nitrite, and that one is ammonium. During storm flow, however, as we are able to see, it increases like a whole lot. At the same point, this one did particulate nitrogen decreases, and ammonium increases as well, which is I kind of find a very significant thing. Yeah, next slide. To test how the nutrient exports are affected with discharge, I ran a regression model, and out of all of the forms of nitrogen, like this one was more significant than it was the p-value was like to the -6. So I kind of found that very significant. The only thing that I will remark on it is there was some moments of like really high values of discharge, and that kind of made some outliers onto my data set. So as I'm finishing up looking at how discharge is affecting the nutrient forms and fluxes, I'll be able to see if that holds true when I look more into with the outliers and how. So what can we conclude from this? Pretty much DON concentration is significantly different in the base and storm flow, primarily in the base. We can also conclude that DON contributes the most to the total nitrogen at Wailuku River, both at base and storm flow. And that for fluxes, the DON flux is known to has a trend of it decreases with the rise in discharge. Yeah. So a future study, I would like to see if what is the particular reason behind that. And I'd like to thank you all for listening to my talk today. My fellow acknowledgements are all here, and I'll be happy to take any questions. Yes.
What's your definition of storm flow? I mean, how much about base flow?
Oh, I'm glad you asked that. So for the cutoff for when it was considered base flow and storm flow, I was running a program for the regression, and the thing was it only took in units where the nutrient concentrations were milligrams per liter. It was like a pretty much, and then the discharge was cubic feet per second. So from our cutoff is like if it was greater than 130 cubic feet per second, we considered that to be storm flow, and anything less than that was considered base.
Just this is a GCP, if you get the long-term flow data from gauge, the programs you can plug in, calculate what is the base flow for that stream. It might be way more
Yeah,
objectively.
yeah, I'll actually consider doing that when I finalize everything for the end of the semester.
Are there kind of trickle down effects of when these rivers flow into the ocean, like the impact that they may have on the reefs or the wildlife there because of these changes in nutrient levels?
Well, as you know, the whole thing with climate change is it's still pretty much, we're still kind of learning the impacts of climate change and how that is going to be affecting, especially coastal systems because of primary productivity. I'm still looking into like if there's any particular trickle down effects, but if I find anything, I will definitely say something.
Yeah, please do.
Yeah.
Rachel, my question is similar to Emma's, but why should we care about dissolved organic nitrogen, the other forms of nitrogen in the water? Like what potential consequences could happen if these change or obviously we know about storm flows that, causing bacterial, blooms on the coast. But do you have any comment on that?
I'm still pretty much researching into that. Like I'm actually getting the finalization of like seeing the consequences or like how dissolved organic nitrogen is going to play a role, whether it's good or bad. But as soon as I get that information,